So, all right, let's get started. So far, we discussed about the rounding functions as part of DAX, and also we have seen the logical functions and the information functions like is error, if error, is blank. So we have seen those kind of functions so far. Okay, and today we will continue with exploring the aggregation functions. This is one of the most basic but also important functions. Okay, so the aggregation functions. Okay, what is an aggregation? In simple term, the aggregation is nothing but summarization. Summarization. I just write it here. Summarization. So what is summarization? Again, it's an aggregation. Let's say I have a column by the name of sales. Okay, in a table, I have a column by the name of sales. In the sales column, I have something like 100, 200, 120, and 130. If I wanted to if I want to find out the total, so we'll be using a function called sum in DAX. Okay, this is called aggregation. We don't, whatever we see here is the transaction detail. We don't want to see the detailed records. We need to see the aggregation, or we need to perform some kind of aggregation. So in this case, we use sum function. And likewise, you have average function, min functions, minimum to find out the minimum. We have min, and to find out the max functions are available. So in this case, 300, 400, 550. This is the total. If you use sum function in DAX. Okay. So to obtain the total sales, in this case, we have used a sum function. Okay, and like a sum function, count is also one of the commonly used aggregation function. Now let us take a look at the count family of functions in Power BI DAX. The count family includes 7 DAX functions: count, count A, count X, count X, count blank, count rows, and distinct count. Let us explore each and every count or related functions. So here I have grouped 2 different categories of count family of functions. Okay, the first one is excluding blanks. The second one is including blanks. When you use these 4 functions while doing the count, it'll exclude the blank values. For example, in the case of count function, the count function count the number of values in a column that contain number, data type, or dates or strings. And also the count function does not count blank values and Boolean values. But if Boolean values along with numerical values and categorical data, it will count, but only Boolean value, it will not count. That is a limitation with count function. Next one is the count A function. Count A function, count the number of values or cells in a column that contains number, date, strings, including Boolean values. In the case of count Boolean, it will not count the number of values in a Boolean column, a column which has a Boolean value. Okay, but here all the data types are possible: number, date, strings, and including Boolean values. And also the count A function does not count blank cells. As the name suggests, right? A means all the data type, but it excludes the blanks. It will not count the blank values. Supposing you have listen of 1, 2, 3, and you have some blank value, and 4 is there. If I use a count function, so it will say 4 values are there in this column. Okay, it will not do the sum. It will simply count how many number of occurrence of values are there, and but it will exclude the blank value. Both in the all these 4 count functions, it will simply ignore the blank values. It will not take into account of the blank values. That's what I'm trying to say. And the next one is the count X function. The count X function counts the number of values in a column that contains numbers, dates, strings. Okay, but count X function does not count blank values. Like count function, the count function also, it will not count the values that are part of your boolean. Okay, boolean with numerical values. Okay, sorry, boolean values. But if boolean with numerical values and categorical data, it will count. But only boolean values, it will not count. Which one? The countx function. But in countx function, we can do filters. The difference between count and countx is here we can use an expression. Using expression, we can do filters. Okay, based on some condition, we want to count, perform a count. For example, you want to count how many number of male customers are there. Okay, so in that case, you can use a filter condition where the count x. Whenever you see any function that ends with x in DAX, this is called iterating function. This is called your iterating function. And so the in the case of the function that ends with x, right? It's called as iterating function. It takes two arguments. The first argument is your table name, and the second argument you can use an expression. Since count x takes two arguments, unlike count and count a function, right? So here in the second argument, you specify the filtering criteria. Okay, so that is the advantage of the iterating function, and it excludes the blanks and boolean data. That's what I mentioned. And next one is the count ax function. The count ax function, they count the number of values in a column that contains number, date, strings, and boolean values, like your count a function. The count a and count ax more or less same. Again, so like count a and other functions, right? The count ax function, it will not count the blank values in a column, but using count ax, because this function also ends with x. The count x, count ax, these two functions are iterating function. Okay, so since it is an iterating function, it takes two arguments. First argument is your table name. The second argument is your expression. Using the expression, you can specify, you can do the filtering. Okay. See, that's what the difference between the countx and countx. So we have two iterating function here. So what is the difference between these two? So like countx function, countax function also works on number, date, string. But in addition to number, date, string, the countax function works with Boolean values also. If you have a Boolean column, right, so it will work on that also. That is the only difference. Otherwise, these two are more or less same. In both the cases, you can use expression. Because of expression, you can in the place of expression, right, you can use some filtering condition. Okay, so that is the difference. That's all. Okay, in these four functions, it doesn't take into account of the blank values that are there in your column. The next one is blank values. So these three functions will include the blank values. Distinct count, it counts distinct values in a column including blanks. For example, you have 1, 2, 3, and you have a blank value and then 4. So when you use the distinct count, and here it will show the 5. It will include the blank values also. The next one is count blanks. Counts the number of blanks in a column. For the same data set, when you use the count blanks, it will say 1. How many number of blank values are there in a column? If you want to check it, you can use count blanks. Next one is the count rows function. They count the number of rows in a table. This function, okay? So if you want to find the total number of records in a table, you can use this one. But in this case, it will take into account of the blank values also. Got it? That is the hope you understood the difference between each count function or the amongst the count functions. Now what I do is I just jump into the Power BI desktop. Already I have opened a Power BI desktop here, and if you see here, let me just go to the first page. This is my data set. Okay, I just go to the data view. Look here. Here I already loaded the data. For the sake of illustration, I have used a simple data set or less number of records, okay, and the less number of columns. Here we have only 5 columns and less number of records. And in the column, if you see the customer name column, we have units sold, sales, and active. This is a Boolean data type. This column is a Boolean data type. and this is a text data type, and this is the number data type. Okay. Now I just go to the report canvas. I have used a table here, table visual. Instead of going every now and then to the data view, right? Better I used a table and I dragged and dropped all the columns that are part of this table so that we can cross verify. So look here, I have already used different chords here. Where is that count AX, count A measure? Mm, okay, I have used count function for this one. The moment when you select the chord visual, right? Look here, this one got highlighted. So this is what chord already we discussed as part of the data visualization section. And also I have shown you in the previous session also, right? How to you know what is chord, and with chord how we can check it. So this is the chord thing, chord visual. I just click on the, look here, the moment when I select this chord, the corresponding visual got also highlighted. It is a one to this is a chord, and also the in this case I've used a measure got highlighted. This measure got highlighted. When you click on this measure, you can see that what formula or what calculation I'm doing it as part of this measure. This is a measure, okay, and in this case count sales by customer sales. So I just use the count function in order to find out the total number of values that are available in this sales column. Now, if you see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 value, 10 records are there. Total number of records are 10. But out of the 10, we have 1, 2, 3, 4, 5, 6. You can see 6 non-blank values. Non-blank values. The rest of them are, say, this is a blank value, this is a blank value, blank and blank. 4 blank values are there. 6 non-blank values are there. If you add these two, we will get to know the total number of records. Out of 10 records, we can see the non-blank values in sales column are 6. The total number of values that are part of the sales, but it excludes the blank value. That is what your count function. And then the next one is we have seen the count A function. Look here, this is the count A function. Already I have written a measure here. And if you click on the count A measure, you can see that sales by customer. In this case, the customer is a text data type. So in this case, let's say, yeah, this is a text data type. If you see here, out of 10 records, only one record as a blank value for this customer, right? So 10 values are supposed to be there, but only one is blank value. Count A also, like count function, it simply excludes the blank value and it counts the rest of the values. So in total, we have 10 records. Of the 10 records, excluding the blank value, we have 9 values are there. Got it? So that is what we can conclude it. Now the next one is the count A and count X function. Look here, this is a count X function. This is my one second. This is my count X function. The moment when I clicked selected this card, automatically the measure which I used it, gets highlighted here. When how do you make sure that this is a measure or column name? If you see the calculator along with the the measure name, you can make sure that this is a measure. Okay, the measure is something like so you are performing some kind of calculations or you are using some kind of formula here. So in this case, the count X, when I clicked on this, I can see that I already created a measure for count X. The count X, the first argument, as I told you, count X is an iterating function, and it takes two arguments. The first argument is your table name. The second argument can be your expression. In this case, I did not use any filtering, anything. I'm using the same column customer again. In the case of count X also, it is doing the good job. Okay, and the total number of, okay, let me just, the total number of values in this column is 9. So the count A and count X more or less it matches. For example, what I do is I just select the count X measure Instead of 1 second, here we have active. Instead of using a context function on the text data type, I'm going to use it on Boolean data type. Let us see what happens. The customer is a text data type. The context function works with a column which is a text data type. Now I just see, for illustration purpose, I'm going to intentionally select a column with a Boolean data type. Okay, the active column in this table is a Boolean data type. We can see only the true or false. And I just click close. Look here, it generated an error here. Look here, when I click on this, it shows could not load the data for this model. The function counters cannot work with values of type Boolean. You understood now, right? So countEx function, like count function, it will not work with Boolean data type. The column with the Boolean data type, both the count and countEx function will not work. You need to remember this. Whereas in the case of count AX, okay, I told you the count, let me just go ahead and replace this with the previous thing. Customer is a column I have already created. I'll look here. I just press enter. Fine. But the context function will work with the number, date, and strings text. Okay. Whereas the context function, it will not work with Boolean like count function. Where is the count function? This is the count function. Okay. These two will not work with Boolean data type. Okay. Next one is the count AX. I just select this one and it shows the count AX related measure got highlighted here on the right side. I just click on this and like count X function, the count AX function also takes two arguments. First one is the table and second one is your expression. So in this case, I have used a filter function. So you might be wondering, in the case of count X, or you take any function that ends with X, it takes two arguments. The first argument supposed to be a what? Table. I should have mentioned the table name, but I'm using something called filter. The filter function, what it does is behind the scene, it returns a table. In this case, those customers are active. That means true. Filter only those records. Okay, so this one, the filter function returns a table. Hence, the first argument is a table. What we have mentioned here, it's correct. Though I did not specify the table name directly, I use a filter function because the filter function can generate a table. So in this case, what will happen is the filter function will hold, the filter function will generate a table. That table will hold only the records specific to the active thing. Okay, those customers are active, only those records gets filtered. And second one is the expression. Okay, look here. So only true. Count AX. Look here. I have used the active, this column. This is the column I have used it in count AX function, right? So this is the one for count AX. I use this column active. Active column is a Boolean data type. Okay, and here if you see here, count AX function, right? So yeah, true, false, and blank value. Let me just show you one more time. Let me just check one more time. Yeah, sorry. Here in this case, count AX, I've used it on the customer column. Sorry. Customer column, the count AX displays only three values here. 1 second, let me just. Why only three records? Because we have used a condition here. The sales by customer active equal to true. So here, if you see, if you look at only the true, the status active, true related records, you need to ignore the rest of the values, right? Here you have blank value, here you have blank value. Only three records have true values in the active column. So out of the three true values, right? sorry, 4 true values are there. 1, 2, 3, 4. 4 true values are there. Okay, for these 4 true values, we want to return the customer name. But in this case, we don't have any customer name. And for this true 22 is there, true Baron is there, true Baron is there. Hence, it returns 3. Here, basically, we are filtering this table where the active is true. So in that case, only 4 records will be there behind the scene. Okay, in the memory, only 4 records will be there. Of the 4 records, the first record, we don't have any blank values. Sorry, we don't have any customer name here. It has a blank value. Like other functions, count ex function also ignore the blank record, and it will take into account of the other 3 true values, 1, 2, 3, and it returns 3. Got it? Hope you understood with this example what is count function, what is count x function, count a function, and count ax function. The next one is blank count. It is pretty simple, and I selected this card visual, and the corresponding the measure got highlighted on the right side just beneath the field space. When I click on the count blank, I can see that I've used the customer name here, column here, customer's name. It shows only one value, has a blank here, right? Only in the customer's name, you could see only one value. Very good. So next one is blank count sales M. In the sales column, can you count how many number of blank values are there? So of the 10 values, right? So 1, 2, 3, 4. 4 values, we have blank values here. And the next one is measure. So when I selected this card visual, the corresponding measure got highlighted on the right side just beneath the fields pane. Just click on the measure. You can see count rows sales by customer. What is sales by customer? Is a table name. Look here, this is a table name, right? The sales by customer is the table name. Look at here. So in this table, how many number of records are there? Which including the blank values. Okay, it has the blank values also in it. Okay. So very good. So hope you understood the difference between count different count functions. So we started with exploring count, and then we have seen count x, count e, and count ax, and both the count and count x function, it works only on the number, date, and string data type. It doesn't work with the Boolean data type. Okay. And also the the count ax, count a, count ax function, right? These functions simply ignores or exclude the blank records. It will not take into account of the blank values while counting the number of values in each cell. Okay. So now you understood the difference between count and count x. Okay. The only similarity here is number, date, string, data type. In count and count x will work. It will not work with the Boolean data type, and it simply ignores the blank values. The next one is count A and count AX. The simple way to remember count A and count AX, you just think A is all data type, something like that. Okay. Both count A and count AX works with the date, number, string, including Boolean values. Okay, and both these function does not count the blank values. Like count A, but in the count AX function we can do filters. Okay, that is the advantage of the iterating function. Those functions that ends with x, count x and count AX, these two are iterating functions. The advantage of iterating function, we can include the filters. For example, I just click on this once again, and if you look at here, the corresponding measure got highlighted on the right side, and here I have used the filter condition. Okay, you can filter the you can apply some kind of filtering condition. I don't want to count all the records based on some condition. I wanted to count it. So how many customers are active currently? Can you count only those customers? So in this case, 3. Got it? Hope you understood how to use all these family of count functions. It is pretty simple, isn't it? The next one is the average functions in DAX. Okay. Now we'll take a look at, there are 3 functions are available as part of the average family. The one is the simple plain vanilla average function. And the next one is the average A function. There's an average A function, and we have, the lastly we have average X. Average A, average X functions are available. Average is pretty straightforward. In the case of average, right? So the when you pass any column to this average function, it will return the average of all the numbers in that column. For example, you have something called sales amount column. Okay, in the sales data, it is available. If you pass this column as an argument, it returns the average sales amount in this table. It takes all the numbers in a column, and then it returns the average of all the sales amount values. So here the syntax is like this. The average is a measure name. The average sales is the measure name, and the equal, and then followed by this you need to specify the equal sign operator, and then the DAX function. The DAX function in this case is average. Average is a DAX function. Okay, and then you need to use the parenthesis. Okay, and then you need to specify the table name here, and then so you need to specify the column name. Okay, so how you can reference a column? Obviously, you need to specify the table name in this inside the square bracket, and you need to specify the column name to create a measure wherein if you want to perform any average, you can do it. This is pretty straightforward. Next, we will okay. So basically, this function, the average function, it takes the specified column as an argument, as I have shown here, right? So it takes the specified column. In this case, it's sales amount. Okay, it takes this specific column as an argument and finds the average values in that column. But the average function does not support logical value and text value. Cells with a zero value are included. For example, in the sales amount, for a specific value, we have zero. It'll work. Okay, and if the data type is integer, numeric, decimal, average skip the null value. If you have any null value for a column which is of integer or decimal, right, it will skip the null value. Okay, like count function, the average function also skip the null value in the case of a column which is an integer, numeric, decimal. First of all, the average function, it will not work on the text value and logic value. Obviously, there is no point in performing average on a text column, isn't it? It will not work. Okay, next one is the average A function. The average A function takes a column and average the numbers, but also handles non-numerical data types according to some rules. Okay, it support logical values. Okay, and then it does not support logical value, and no, as per the documentation, it support logical values. Logical value true count as true. It consider, if you have a column which is having which is of a logical data type, Boolean data type. For true, it considers as a 1, and false, it count as a 0. Okay, and values that contain non-numeric text, it count as 0. Okay, and what do you mean by non-numeric text? Non-numeric text is something like, I don't know. Okay, non-numeric text is something like you have something like a 2 3 4, right? This is a text value, but it is a non-numeric text. For example, 2 3 4 is a text data type. So it is a numeric text data type. Okay, you can convert the numeric value. Okay, you can, even if you convert the text into numeric of this type of value, it will get converted as a numeric value. But in this case, since the numeric value is combined with the text, hence you cannot convert it. That is what I meant. Values that contain non-numeric text like this, it will be counted as 0 in the case of average. And the empty text, for example, in the customer name, you have blank, text, blank string is there. Okay, it counts as 0. For empty string, it counts as 0, and non-numeric text, it counts as 0. For the logical value, true, it counts as 1, and false, it counts as 0. Okay. It support logical values also. That's what I'm trying to say. And the next one is the average x. Okay, now what we will do is we'll get into action and we will start use the average function. Okay, here I did not. Okay, here I've used the average function. So this is the thing here. So when I selected this visual, right, what type of visual is that? It's a table visual. And the columns that I use it in this visual got highlighted on the right side. Look here, here I have used 3 measures and 1 column name. Customer name, I just dragged and dropped it here. We can see these customers and the average quantity, right? So for this one, look here. In this case, I've used average function, and second one is average A and average X. As I told you, right? So average X, the function which ends with X is a iterating function. We'll first explore what is average and average measure. So here the average I already have seen, right? So units sold. This is the column I used it. And if you see the data here, right? So units sold, we can see 10. Average quantity 20 to 10. Okay. It takes average of all the things, right? It gives me 9.29, something like that. Okay. 9.29. And okay, here in this case, average A measure too. Now we will go here. Customer active. So I have used the Boolean data type column. So if you see here active, how many trues are there? 4. And one, this is 0. This is false is considered as 0. Okay. And here in this case, average XM, if you see here, let me just check here. I just got 10 and 11.33, 15. Okay, let me see average X, what logic I use it. Okay, here in this case, unit sold is greater than 6. Okay, unit sold is greater than 6. You filter that one. See, the first argument is a table. In this case, I filtered those records that have units sold more than 6. Okay, and the units sold, sales by customer. So, and then what it is, you select only the records wherein the unit sold was more than 6, and for those records you do the average on the unit sold column. So what is my unit sold column? This is the one, right? So in this case, what happens? More than 6. So if you see here units sold, it will exclude this one, and 0 also will get excluded, because the rule is units sold is more than 6. So 15, and look here, the 15, it comes just like that. And then the Baron is, in this case, Baron, we have 3 records are there. So 24 and 34. 34 divided by 3, how much? I know the answer, but still 11.33. 11.33. See, for Baron, we have 3 records, right? Hence, what it does is it does the average for Baron 11.33. Whereas in the case of Larry, we have only 1 record. Hence, nothing to do with the average, right? So since you have only 1 value, you are dividing this one by 1. And the next one is 22. 22 is also only 1 value is there. Hence, it displays 10. Okay. So in the case of average X, we have used the expression wherein we have used the filter function. In the filter function, we excluded those records that have less than 6, and we consider only those records that have more than 6. And when we did this, we could see that Baron 3 records, it did the average for this one. I'll just show you once again here. Units sold, and the filter sales by customer. Okay, it did that way. Okay, and average A, we will take a look at it one more time. So active records, average A, active records, and in this case, average A. Okay, average A, we can see that I did not use. Okay, in the case of average A, okay, I just See, the point what you need to note down here is the average works with the Boolean data type also. Okay. For that reason, I just used it here. And if you see here, the active records, it considered the true as 1, 1 and the false as 0. Look here in the active column. See, we did an average on the active column, right? Average A. So in the average A works with Boolean data type also. Remember that. So here true is considered as 1 and the true as considered as 1 and true as considered as 1. And we have in barren, we have two ones are there, right? Okay, no, we are not supposed to look at the barren here. And in this case, we have four ones. Okay, and three, but it takes into account of only this one, and 22 is one, and next one is barren is one. Okay, it did not take into account of one more thing, right? So barren, so duplicate. Okay, so 2 divided by 2, yeah, 1 plus 1 is 2, divided by 2 is 1 only, right? In this case, we have, these two are part of barren, so hence it is doing that way. Okay, and this is 1, 1, and here in barren, yes, look here. So that is how it works. And the last one is Larry. Larry, we have false, hence it gives me 0. Okay, got it. That's what we have observed here also. The average X, we have used the units sold is greater than 6, right? So in that case, it ignored this record, it ignored this record, and the rest of the record, what happened? The barren. In the case of barren, the three values are there. So 22, 34. 34 divided by 3 is 11.33, and then this 10, just 10 only, because we don't have more than one value for 22. Okay, and that is the reason why it is doing like this. And the average is the plain thing. Okay, so this is pretty straightforward. And look here, the barren also did the same thing, 11.33, and it is more or less same as this one. But in the case of average, any blank value is there, right? It simply ignores that one. And Chris, let me do one thing. Chris is 0, right? Okay, Chris is 0, hence it includes that as part of the average. And Larry is 15. Here, there is nothing else to add with Larry, because we have only one record. And Reich 6. Okay, but here so more or less both of them are same, average and average X. That's what we can see it here. But in the case of average X, okay, both of them are same, right? But why we are not seeing here 6? Because we have used a filtering criteria here. So more than 6, you take it, right? So in the ends, it is leaving the blank here. In the case of Chris, since it is the unit of sold is more than 6, we have used it. It is showing blank here. Hope you understood. So to summarize, we have seen the average function and average A function and average X function. The average function does not support logical value and text value, whereas the average A function supports the support logical values. It considers the logical values true as 1, false as 0. Okay, and the next one is the average A function, the average X function. Like the average X fun, in the case of average X, it takes two arguments. The first argument is your table name, and second argument is supposed to be your expression. The averages function, enables us to evaluate an expression for each row of table, and it takes the resulting set of values and calculates its arithmetic mean. So you cannot include non-numeric or null values in this one. It does not support logical or Boolean values. Which one? The average X. You need to remember these things very clearly. So, all right.